Good afternoon, children. Once again, welcome to SBRPC online classes for the second topic, children. As we have started in this one, the continued and the completed last class, GOC. And today you have appeared for the exam also. I hope so. You might have performed well because all the points I have covered in the classes, numericals and all, depending upon the formula, we can answer. Correct? Let us move to the topic, hydrocarbons. Hydrocarbons. This is the second topic in organic chemistry. Very important, two organic topics are there, one GOC and one hydrocarbons. Very important topic. In this topic, we have to discuss in detail water classification that already we have done in the earlier topic. Other than that, where they are showing application means their sources, their application related with their classification, isomerism, nature of the carbon atom. Then other than that, we have to discuss separately in detail saturated hydrocarbon, unsaturated hydrocarbons, and as well as aromatic hydrocarbons. These three are actually the subtopic in this topic. In this main topic as hydrocarbon. So here, let us move to the introduction. Introduction. Whatever I am completing this week, children, everything will be there for upcoming exam. That you need to remember. Upcoming Tuesday exam, you'll be having the topic what I am going to start today and going to end by the end of this week. Complete topic will be there. In the introduction, name itself indicates that hydrocarbons are compounds of carbon and hydrogen. These are what, children? Name itself said. These are the compounds of carbon and hydrogen. And one thing we can remember that the basic constituent element are carbon and hydrogen, where hydrogen can be replaced by different functional group. That's why we said that hydrocarbons are the compounds of carbon and hydrogen these we can define. We can define it as these are the compounds of carbon and hydrogen, and their derivatives. And their what? Derivatives. They are called as what, children? They are called as hydrocarbons. They are called as hydrocarbon. One or all hydrogen atom in a hydrocarbon are replaced by functional group. We know very well that whenever we are replacing by the functional group, whenever we are going to replace by the functional group will decide the character. But in this topic, without functional group, just we are dealing with what, children? Only carbon and hydrogen. Only carbon and hydrogen. And another point we need to remember that whenever we are dealing with the hydrocarbon, actually hydrocarbons are extracted from petroleum, from natural gases, and from coal gases. From coal gases. And present situation, if we'll see, the most applicable, or we can say that most useful part of hydrocarbon is LPG, liquefied petroleum gas, compressed natural gas. You have seen that day by day petrol demand is increasing. Correct? One of the substitute for the petrol, we can go for other gases. They too are hydrocarbon, but they are cheaper as compared to petrol. That means that without hydrocarbon, without this compounds of hydrocarbon, we cannot imagine transportation. Or in a simple way, as a fuel, as I said. Earlier days, people used to go with the wood as a fuel. It was the basic, the need for life, to survive for the life, they used to take wood as a fuel. But it has many hazardous effect, or the side effect we can say. Many side effects are there. That's why they have been modified by natural gas, or we can take the liquefied petroleum gas and the compressed natural gas. Another point you need to remember that not only this one, even we are going to the examples liquid natural gas also we are going to, they are using in many of the this one, the automobiles or the transportation, they are referring all these mixture of the gases. In this present topic, we have to see that how these hydrocarbons are going to be classified. Classification. Hydrocarbons, if we'll see, hydrocarbons may be arranged in a open chain. Arrangement of chain only we can decide. It can be arranged in a open chain. It can be arranged in a closed chain. Same this one, just I am making this one. Open chain. It may be closed chain. It may be open chain, it may be a closed chain. In that open chain, again, these open chain hydrocarbons are called as aliphatic hydrocarbon, and they may be saturated or unsaturated. Already we have made all these children saturated or unsaturated. Saturated, carbon-carbon single bond. Unsaturated are again carbon-carbon double bond or carbon-carbon triple bond. In the closed chain, they may be alicyclic, or they may be aromatic. They may be aromatic. And our present topic, hydrocarbons topic, is deals with saturated hydrocarbon, unsaturated hydrocarbons, alicyclic and aromatic. Alicyclic, we are having very little part related with some nomenclature. We don't have preparation and all much in detail, but we are having all these alkane, alkene, alkyne, benzene and their derivatives. This is actually the bits which we have which they have mentioned in the syllabus. They have mentioned that how the hydrocarbons are going to be classified. They are going to be classified on the basis of arrangement of carbon chain. They may be arranged in an open chain. They may be arranged in a closed chain. Let us move toward first one, that is alkanes. Let us move to the first one, that is alkanes. What are alkanes? Alkanes. Alkanes are saturated hydrocarbons. Alkanes are saturated hydrocarbons. Hydrocarbons where carbon atoms are linked by single bond. Carbon atoms linked by single bond. Linked by single bond with other carbon atom. With other carbon atom. Alkanes are called as paraffins. Paraffin. Where para means low. Means low. Fins. Fins represent what? Affinity. Low affinity. Low affinity, we can call it as paraffin. Saturated hydrocarbons where carbon atoms are linked by single bond, they are also called as paraffin. If we are going to take the example, the first member, because alkane have the general formula CnH2n plus 2. This is the general formula to represent alkane. to represent alkane, the general formula is CnH2n plus 2. And the general formula is used to calculate the number of hydrogen atom. What is the use of general formula? General formula is used to calculate the number of hydrogen atom, because root word is known for us. Like the meth, it has 1 carbon atom, it has 2 carbon atom, prop has 3 carbon atom. So it means that based upon the number of carbon atom, root word can be decided. For example, if I am going to take 1 carbon atom number will be the difficulty to write the structure. Once you are practicing, nothing difficult for you. It is called as methane. Same way, C2H6, ethane. Propane, C3H8, called as propane, etc. We can write number of examples are there where all the carbon atoms are linked by single bond. Depending upon the number of carbon atom, meth, eth, prop, but, pent, hex, hept, oct, non, and dec. That means that depending upon the number of carbon atom, we can give their respective word root or the root word. Now the question arises that if they are linked by carbon-carbon single bond, how to represent them? Remember one thing, when we are representing by this one, always we should remember that the carbon atoms, when it is linked by single bond, when they are linked by the single bond, they are having the hybridization as sp3. If we'll see the structure, of the alkane, they are going to show what? sp3 hybridization. Which hybridization? sp3 hybridization for carbon-carbon single bond. Whenever we are dealing with the sp3, remember one thing, one s orbital in the chemical bonding with all the structural representation we'll see, children, here. Even in the last topic also, we were having the bit related with sp3, sp2 and sp. Carbon-carbon single are sp3, carbon-carbon double are sp2, whereas the carbon-carbon single triple are sp hybridization. Therefore, when we are dealing with such hybridization, here if we are going to take the example like methane, carbon is present at the center and 4 hydrogen atoms are present at the 4 corner of a tetrahedron. Remember one thing, between carbon, hydrogen and the carbon, bond angle will be 109.5 degrees. Simple way how to represent the methane, we'll write the carbon at the center and we will write 4 bond link to the carbon. As we know very well that carbon is a tetravalent and carbon shows catenation property. It can the isomerize. Many special characters are there with respect to carbon. That's why carbon and its family are separated as separate branch as organic chemistry. They have separated as what? Organic chemistry. Instead of this one, if I'm going to write their orbital structure, in the orbital structure, we can see that when we will go to this one, we'll see that carbon is present at the center. And every p orbitals are dumbbell in shape. P orbitals are what, children? They are dumbbell in shape. When they are dumbbell in shape, they are going to form carbon atom which are participating in the covalent bond formation. It will be what? sp3 hybridization. sp3 hybridization. Even with respect to the bond, this one also, we can represent it as just the orbital structure we can represent, children. Okay, we can represent the structure CH3 and we can write here surrounded by 4 hydrogen CH4 formula. We can write it as CH4. This is called as orbital structure. We can write it as with respect to this one. Easy to write. One lobe should be smaller, one lobe should be larger, and the bond angle can be written it as 109.5 degree. That's why whenever you are representing the bond angle, need to remember their hybridization. Without hybridization, you cannot represent. It will be difficult to represent over here. And the another bit already we have read. Have you remembered, children? While naming this one, the organic compound, we said whenever we are going to name whenever we are going to name or the nomenclature of organic compound, that time we said, that is many of this one, the concept related with isomerization, related with nomenclature, already we have completed in earlier topic also. Just I'll glance here and we'll solve the question which is given in NCERT text. We can write the heading as nomenclature and isomerism. Nomenclature and isomerism in alkene. In alkanes. In alkanes. Rules will be same while deciding the nomenclature for the IUPAC system. Longest chain will be parental chain. Longest chain will be what? Parental chain. But remember here, when we are deciding the common system, according to the common system, always we should write the name can be given it as normal, iso, neo, tertiary, depending upon the arrangement of carbon atoms. Depending upon what? Arrangement of carbon atoms, that we will discuss in isomerism. That will discuss in the isomerism. Let me repeat the sentence. As we said in the earlier topic, IUPAC system. IUPAC system of the nomenclature will be same as what we said in the earlier topic. That is, longest chain will be treated as a parental chain and the alkyl group will be treated as a substituent. Alkyl group will be treated as a substituent. If, for example, if I am going to take one carbon atom with 4 hydrogen atom, root word will be meth, and for the ane suffix will be ane for alkane. That's why we'll call it as methane. Methane. Suffix for alkane is ane. For saturated hydrocarbon, suffix will be ane. Same way, if we are going to write with 3 carbon atoms, CH3, CH2, CH3. We can call it as prop plus ane. We can name it as propane. We can name it as what? Propane. If we are going to write condensed formula also, no problem at all. CH3, CH2, 3 times and CH3. All the 3 carbon atoms are arranged in an open chain. 1 plus 3, 4, 4 plus 1, 5. We can call it as pentane. According to the common system, all the carbon atoms are arranged in an open chain. You can call it as a normal pentane. You can call it as a normal pentane. That's why, as I said now, for the nomenclature, it will be most important part of this one. That is on the basis of, according to the common system. 1 minute. Molecular formula. Common system. And IUPAC system. According to common system, according to IUPAC system, the respective name has to be given. The respective name has to be given. Instead of taking methyl ethane, I'll take some long example over here, children. We'll take the right molecular formula as CH3, CH2, 3 times CH3. It means that all the carbon atoms are arranged in open chain. I can call it as normal pentane. Normal pentane. But according to the IUPAC system, we can call in general as pentane. We can call it as pentane only. Molecular formula is same, means 5 carbon atom chain only. If one of the carbon atom is branch, one of the carbon atom is branch, 1, 2, 3, 4 and 5. 4 and 5. Second carbon atom is containing methyl group. We can call it as iso. We can call it as iso. It will be 1, 2, 3, 4 and 5. We can call it as isopentane. But according to the IUPAC system, this is carbon atom number 1, 2, 3 and 4. Numbering can be done in the IUPAC system. That's why second carbon atom has methyl group. We can write it as 2-methyl butane. 2-methyl butane. We can call it as what, children? 2-methyl butane. 1 minute. So here we can take it as 2-methyl butane. Same way, to the same molecular formula, to same this molecular formula, I'll write it as CH3, C, CH3, this is CH3, and this is also CH3. You can see here 1, 2, 3, 4, and 5. 5 carbon atoms are there, which all are branched. Correct? If we'll see all the carbon atoms are branched, 5 carbon atoms are there. According to the common system, they are called as Neopentane. They are called as Neopentane. They are called as what? Neopentane. But according to the common system, 1, 2, according to the IUPAC system, according to common system, you have called as neopentane. According to the parental chain, the longest chain is 3 carbon atom. At the second carbon atom, we are having 2 methyl group. I can call it as 2,2-dimethyl propane. 2,2-dimethyl, what, children? Propane. 2,2-dimethyl propane. Therefore, whenever we are deciding the name on the basis of the common system, because common system is a failure method, because earlier we have read about the the history behind the common system, that without the sources they were unable to decide the name. But IUPAC system is a successful method. One of the 2 example I have taken here, children. Will not extend this one. Let us move to isomerism. All these are, we can treat it as chain isomer also. First I'll write, later I'll go to the same example, children. Chain isomer, isomerism in alkene. Isomerism in alkene. Alkane shows structural isomerism as a chain isomerism. Very simple to understand that what is the chain isomerism. Whatever the name has been designated over there, that will be different. It means that 2 or more molecules having same molecular formula, but they have different arrangement of carbon chain. Carbon chain is different. Arrangement of carbon chain is different. Is different. For example, just now we have taken the example. Other than that, we can take some more example. Like the 6 carbon atoms are there. CH3, CH2, 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 CH3. Carbon atom number 1, 2, 3, 4, 5, and 6. 6 carbon atom I can arrange in open chain, whereas the one of the carbon atom I can make it as a branch. One of the carbon atom at the second position, I can make it as a branch. 1, 2, 3, 4, 5, and 6. Because in the carbon chain or the chain isomerism, parental chain should be different. That keynote we need to remember. Here the parental chain has 6 carbon atom. Here parental chain has 5 carbon atom. I can take one more 5 carbon atom chain as CH2, CH, CH3. Correct? But remember here, this is called as iso, but this is called as secondary. This is iso and this is secondary. CH3, CH2, CH, 1, 2, 3, 4, 5, and 6. 6. According to the common system, this is called as normal. This is called as iso and this is called as secondary. One of the simplest way, as I said, to remember with respect to name. Second carbon atom, there is a methyl group called as iso. third carbon atom, there is a methyl group, you can call it as a secondary. If the second carbon atom is completely branched, CH3, CCH3, correct? Like this carbon chain is there. You can call it as what, children? This you can call it as a neo. This you can call it as a neo. All these are the common system. But when you are writing with respect to the chain isomer, parental chain must be different. Number of parental chain must be different. Parental means what? Parental carbon chain. Parental carbon chain must be different. They are called as chain isomer. They are called as what, children? Chain isomer. As in NCERT 13.1. 13.1, they have given one question. If you have the NCERT book, you just to see over there, children. They have asked the question related with 13.1. Draw the different chain isomer of C6H14. Exercise text question 13.1. 13.1, solve yourself how the 6 carbon atom are arranged in open chain. One of the carbon atom is branch, 2 carbon atom. Position of alkyl group can be shifted by changing the position of what? Methyl group. Either we have taken the longest chain will be treated as a parental chain. Like that with C6H14. Like this with C6H14, we can get the number of isomer. Or we can say that number of 5 probable isomers are possible. 5 probable isomers are possible. Try to write all these because without practicing this one, children, it cannot be, you cannot be able to write. Without writing the structure, just to make all the 6 carbon atom open chain, 1 carbon atom you make branch at the second carbon atom, other carbon atom you can make it at the third, or you can make 2 more carbon atom branch by making it as a butane. You can make all the carbon atoms branch to make it as a neocarbon atom. That means that all the possibilities are there to decide the what a chain isomer. But as a whole, the chain isomer, we are dealing with only hydrocarbon without functional group. Because if the carbon and hydrogen atoms are replaced by functional group, that time the question may be arises related with the different types of isomerism. Different type of what? Isomerism. The next point is related with nature of carbon atoms. Nature of carbon atoms. How the carbon atom nature can be decided? Carbon atom nature can be decided on the basis of number of carbon atom linked to other carbon atom. If that case, methane will be alone, no carbon at all. Yes, question will arise now. Methane is alone, CH4, no carbon at all to the neighboring, this one, the methane, carbon. Whereas if I am going to take ethane, if I am going to take ethane, I'll write it as CH3, 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 CH3. The nature of the carbon atom decide on the basis of what? Neighboring carbon atom. It may be neighboring carbon atom. It may be dependent. May be primary, designated as 1 degree, may be secondary, designated as 2 degree, tertiary, which are designated as 3 degree, and the quaternary, which are designated as 4 degree. 4 degree. So, nature of the carbon atom, on what basis we are deciding? On the basis of number of neighboring carbon atom. They may be primary, they may be secondary, they may be tertiary, they may be quaternary. They may be quaternary. Come to the example. Here one carbon atom is bonded with other carbon atom. That's why both will be treated as primary. This is also primary, this is also primary, because this methyl is neighbor to this methyl is neighbor to this. This carbon atom is alone, no neighboring carbon atom, but even though it is treated as primary, it is treated as what? A primary. If I am going to take CH3, CH2, okay, CH2, CH3. Always remember that terminal carbon atoms will be primary. Terminal means what? CH3. This is primary carbon atom. This is primary. Both the terminals are primary and CH2 will be secondary. Now you can decide yourself how to decide. Just I'll write the structure. Later you tell me how to decide. Here carbon atom is alone, no neighboring carbon atom. It is a primary. This carbon is neighbor to this carbon is neighbor to this. Both are primary. Okay, this carbon atom is neighbor to this is a primary, but this carbon atom is neighbor to right and left two carbon atom, that's why it is a secondary. And the last one is neighbor to only one carbon atom, it is a primary. Same way, if I am going to write some more examples here, CH3, CH2, CH3, CH3. No neighboring here this side, only one side, that's why this is a primary. All terminal are primary, I said. Maybe right, left and top, all are primary. CH2 is secondary. CH3 side, it is having carbon, it is a tertiary. It is what? A tertiary. I'll write one more example. CH3, 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 CH3. Okay. All terminals are primary, as I said already. Primary, primary, and primary. This center carbon atom, all the side is surrounded by carbon. That's why this is a quaternary. That's why this is a quaternary. That means that primary carbon atoms are one, which are surrounded by at least one carbon or no carbon. They are called as primary carbon atom. They are called as what? Primary carbon atom. So here we can say that primary carbon atoms are those. Primary carbon atoms are those which are surrounded by one carbon atom or no carbon atom. Whereas a secondary, which are surrounded two side by carbon, they are called as secondary. If they are surrounded three side, they are tertiary. If they are surrounded all the side four carbon atoms, they are called as quaternary. That means that primary, secondary, tertiary, you can decide on the basis of number of carbon atom. Even you can decide on the basis of number of hydrogen atoms also, children. You can decide on the basis of number of hydrogen atom, because carbon is bounded to carbon. To satisfy the valency, remaining will be hydrogen. Yes, correct. That's why when we are dealing with such molecule, always we should see that terminal, all CH3 group are primary, CH2 are secondary, CH are tertiary, C is quaternary. All the side are carbon. Okay, no hydrogen. No hydrogen is quaternary. Correct. No hydrogen is quaternary. Correct. One hydrogen is tertiary. Two hydrogen is secondary. Three hydrogen or the four hydrogen is primary. In that way also we can decide, or this way also we can decide. The primary, secondary, and the tertiary, depending upon this one. Many times they have asked the question in the theory paper also. For the 1-2 marks, bit will be there in the part D. That time 3-4 molecules will be given over there. They will ask you to identify that which are containing, means you have to identify that which carbon atoms are primary and which carbon atoms are secondary. Which carbon atoms are secondary. Okay. Some questions, 2-3 questions are there. After those questions, we'll move to method of preparation, children. Okay. Let us move to what? Question 13.1 already I have solved to you. The 13.2 is very simple to answer. 13.3 they have given in the question paper. Sorry, in the NCERT book, that 13.3. 13.3 in text question, in solved question they said, write the IUPAC name of, write structure and IUPAC name of different bits they have given. First bit, how they have given in the book, I am writing in the same way. You open the book and see CH2, CH3 taken thrice. Okay. Then second one, leave some space and I'll write CH3 taken twice, C2H5 taken twice. Third we'll write afterwards. So we'll see that they said to write the structure and IUPAC name of. Here they said the 3-methyl group. First we'll write the open chain CH2C. Correct? 3 methyl groups are there. This side also. 3 methyl groups that side also. Here also 3 methyl group. That side also 3 methyl group. We'll write here. Correct? We'll decide the longest parental chain. Sum of lowest locant should be followed. Number 1, 2, 3, 4, 5. If I'll go that direction also, 1, 2, 3, 4. That means that second carbon atom 2 methyl group, 4 carbon atom 2 methyl group. If I'm going to move this direction, opposite direction also it will be same. At the second carbon atom we are having 2 methyl group. At the fourth carbon atom we are having 2 methyl group. So totally we are having how many methyl group, children? 4 methyl group. That's why we can write it as 2, 2, 4, 4 tetramethyl pentane. Tetramethyl pentane. Same way for this second question. See, 2 methyl group are there. Okay. To this 2 C2H5 group are there. C2H5. Okay. C2H5. This side also I'll write. Better you write CH2, CH3. If you are having any this one, is it visible now? Yes, CH2, CH3. Longest chain we'll see here, children. 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Means I can take this as carbon atom number 1. I'll take the carbon atom number 1. This I'll take it as a second carbon atom, third carbon atom, fourth and fifth, because 2 are there. At the third carbon atom, I am having 2 methyl group. Correct? At the third carbon atom, 2 methyl groups are there. That's why name can be given as 3,3 dimethyl pentane. 3,3 dimethyl pentane. One more third last bit is there, that I'll say, children. What is the third bit? Third bit is what? Tetra tertiary butyl methane. Tetra tertiary butyl methane. They said to write the structure. Then they said to write IUPAC naming. Okay. We'll write tetra tertiary. Tertiary butyl, when it comes, you need to remember that 4 atoms are there which are tertiary, like this. Parental chain is methane. So it means that I should write methane at the center. For the side, all the 4 side, 4 tertiary butyl groups are there. Correct? 4 tertiary butyl. 1, 2, 3, 4. Correct? Same way. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Like that 4 are there. Correct? 4 side are there. Is it visible? Okay. 4 side we are going to write this one, the parental. Now we have to decide parental chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You go in any of the direction. 1, 2, 3, 4, and 5. We are getting 5 carbon atom only. That's why I will write here on the basis of what we said, that when we are going for the longest chain, always we should see that on the basis of what, children? We should see that the number of carbon atom, the parental chain must get what? Lowest locant, and as well as sum of lowest locant. Okay, 1, 2, 3, 4, and 5. Sometimes when the molecule is complicated, we are taking the common system itself as a, we'll club the both the common system and as well as IUPAC system. At the third carbon atom, you can see 2 tertiary butyl group are there. Yes or no? 2 tertiary butyl group are there. That's why I can write 3,3 ditertiary butyl. Then 2,2,4,4 2,2,4,4 tetramethyl. It will be pentane. What I should write here? 3,3 ditertiary butyl. 3,3 ditertiary butyl. Then 2,2,4,4 tetramethyl. How many carbon atom are there in a parental chain? Parental chain has 5 carbon atom. I can write it as pentane. Okay, still like this, many questions are there. Like in the 13.3, 13.4, we are having many structures to write this one. IUPAC name are given to you. You have to write the structure, or structure will be given to you. You have to write the IUPAC name. We cannot go all those this one, children. Just one or the two which are the typical. I have solved a remaining example. If any doubt, anything are there, you can post a doubt to me. Okay, let us move to what? Methods of preparation of alkanes. The most important part of the topic is methods of preparation of alkane. What we have discussed till now, let me summarize in 2 minutes. What are hydrocarbon? What are the sources of hydrocarbon? Where you are finding the applications of hydrocarbon, means users of hydrocarbon. How you are going to classify the hydrocarbon? How to name the hydrocarbon? How to name the hydrocarbon, how the different isomers are going to be represented, and how to decide the nature of carbon atom, maybe primary, secondary, tertiary, and quaternary. Let us move to the next part of the topic, very important part of the topic, methods of preparation of alkenes. Methods of preparation of alkenes. When we are deciding any method of preparation, children, first you need to understand, because the first time you are coming across in the syllabus related with method of preparation, you need to understand that the bond present in alkane are carbon-carbon single bond. Carbon-carbon single bond. It means that your aim is to prepare carbon-carbon single. Your aim is to prepare carbon-carbon single. From where? Correct? From where I should start to get carbon-carbon single? This question is most important. Now, in the type of reactions we said, carbon-carbon double bond or carbon-carbon triple bond can be converted into carbon-carbon single bond by addition reaction. By addition reaction. Have you remembered, children? In the addition reaction we said, so here carbon-carbon double bond or the carbon-carbon triple bond. So here addition reactions are possible where multiple bond are converted into single bond, or we can say that multiple bonded molecule, multiple bonded like the carbon-carbon double bond can be converted into carbon-carbon single bond. Carbon-carbon single bond. These reactions are called as addition reaction. And the first method of preparation is from alkene and alkyne only. In this case, alkene and the alkyne, by addition reaction, number of bonds are reduced. Have you remembered in the classes we said, that is in the type of the reaction we said, Double can be converted into single, triple can be converted into double, double to single. That means that 2 moles has to be added to convert triple to single bond. 1 mole of the reagent should be added to convert double to single. Like that, addition reactions are possible. Okay, let us move to the first method of preparation. And another method of preparation, many named reaction are there. Not only the named reaction, even we are having from other functional group. Like the alkyl halide can be converted into hydrocarbon. Alkyl halide can be converted into hydrocarbon. Even after, because there in the second year syllabus, you can see that alcohol can be converted into hydrocarbon. Even the alkyl halide can be converted into hydrocarbon. Aldehyde, ketone, carboxylic acid, all the functional group can be converted into saturated hydrocarbons. Parental chain will be saturated hydrocarbon, and some cases number of carbon atoms will be same. Some cases number of carbon atom will be reduced. In some cases carbon atoms are going to be increased also. Many of the interesting concepts are there in this, children. Let us move to the first one. That is the method of preparation of this one by using water from alkane. First method of preparation from alkanes. Methods of preparation of alkanes. Methods of preparation of alkanes. The first method of preparation is from alkenes. From alkenes. In alkenes, carbon-carbon double bond by adding hydrogen. By adding hydrogen. This is called as addition of hydrogen. Hydrogenation. Addition of hydrogen. It is a catalytic reduction. Catalytic reduction. Because reduction is addition of hydrogen in presence of catalyst. And this involves adsorption. Adsorption using nickel, platinum, or palladium as a catalyst, which are also called as Sabatier-Sanderson's reduction. Carbon-carbon double bond in presence of what, children? Hydrogen. In presence of hydrogen using the catalytic heat in presence of catalyst. General equation I'm writing. Later we'll write the example. Carbon-carbon single bond. So one hydrogen added to this carbon, another hydrogen to this, remaining all are as it is. Correct? By this method, you cannot prepare methane. By this method, methane cannot be prepared. By this method, methane cannot be prepared because no unsaturated hydrocarbon, because carbon-carbon double bond or the triple bond are called as unsaturated hydrocarbon. No such alkene or the alkyne with only one carbon atom. Therefore, in this reaction, alkenes if I'm going to take the example like CH2, double bond CH2. Always we should go with simplest example, children, while writing in the practicing. Once we'll get this one accustomed with the example, understanding all the example, you take any typical example. Okay, this is ethene. By passing hydrogen gas in presence of nickel as a catalyst, by heating, we'll get it as ethane. We'll get it as what, children? Ethane. CH3, CH3, ethane. Ethane. Same way, if we are going to take CH2, double bond CH, CH3. Same we can write here. By passing hydrogen gas, catalytic reduction in presence of nickel, platinum or palladium as a catalyst, we'll get it as water, propane. Many of the ways are there to represent the reagent. This is propane. converted from propene. Prop 1 ene. Prop 1 ene. Correct? So here we can say that carbon-carbon double bond can be converted into carbon-carbon single bond by addition reaction. By what? Addition reaction. Same way, carbon-carbon triple can also be converted into carbon-carbon single. Carbon-carbon triple by addition. But remember here, this triple bond can be converted into double, double can be further converted into single. That's why instead of adding one hydrogen, we can add 2 moles of hydrogen to get it as single bond, carbon-carbon single bond. Again, same in presence of catalyst. In presence of catalyst. If we are taking CH, triple bond CH, H2 molecule, 2 moles are added in presence of nickel, platinum or palladium as a catalyst. A 2 carbon atom saturated hydrocarbons will get it as a ethane. This is ethane and this is ethane. This is ethane. Ethane. First method of preparation, children, to prepare from alkene and alkane. Still many methods are there. Tomorrow quickly we'll move to the method of preparation. If any doubt, anything are there, you can this one. Because brief introduction I have given before going to the method of preparation. Tomorrow quickly we'll complete all the method of preparation. Then we'll go for physical and chemical properties. Alkanes, there we have to discuss one mechanism is there. In alkene also we are having one mechanism. All those will continue in the next class, children. Okay, we'll wind up here. Thank you, one and all.